Hi friends, this is Naresh. In this class, I am going to explain about centroid of composite sections. In this class, I will explain how to locate the centroid of these composite sections. Coming to the first problem, locate the centroid or center of gravity of the given shaded area. Look at the figure. The base dimension is 100 mm. Here only one dimension is given. So how can we solve this problem? How to locate the centroid for this section? First of all, the given figure is split up into two sections. That is, I consider first one as quarter circle. Quarter circle having dimensions base equal to radius equal to 100 mm and height equal to radius equal to 100 mm. So here base and height equal to 100 mm because it is a quarter circle. Now I consider semicircle as section 2 having dimensions radius small r equal to 50 mm and diameter of semicircle equal to 100 mm. I consider reference axis. I consider x-axis at the bottom edge and y-axis at the left side edge. So this is y-axis and this is x-axis. Now this is the origin. O is the origin. Now in this slide I am going to explain some basic formulas for centroids. This is a semicircle having radius capital R and CZ is the centroid or center of gravity of a semicircle at a distance of 4r by 3 pi 4r by 3 pi from baseline. This is a straight line called base. From base to centroid the distance is 4r by 3 pi and from curved surface to centroid the distance is r minus 4r by 3 pi. Total the length is radius equal to radius and this one the given semicircle is symmetric about x-axis. Therefore the centroid lies on this line only. So therefore the total length 2r divided into two equal parts, that is capital R and capital R. Therefore here CZ lies at 4r by 3 pi from straight edge and r minus 4r by 3 pi from curved surface. Now coming to the quarter circle having radius capital R and the centroid lies at a distance of 4r by 3 pi and 4r by 3 pi from right angle corner. This is a right angle corner because this is horizontal line, this is vertical line. Therefore the angle between these two lines is 90 degrees. So this right angle edge. Therefore the centroid of a quarter circle lies at a distance of 4r by 3 pi from right angle corner and r minus 4r by 3 pi from curved surfaces. Now coming to the problem, first section is a quarter circle having radius capital R equal to 100 mm. Therefore the area of a quarter circle A1 equal to pi r square by 4, that is pi into 100 square by 4 equal to 7853.98 mm square. Similarly small r equal to radius of a semicircle and radius A2 equal to pi r square by 2 equal to 3926.99 mm square. Now C1 is the centroid of a quarter circle. From our previous slide, the centroid C1 lies at a distance of 4r by 3 pi 4r by 3 pi from right angle corner and 4r by 3 pi from x-axis. Now similarly, C2 is the centroid of a semicircle at a distance of 4r by 3 pi 4r by 3 pi from y-axis and r at a distance of r from x-axis. Here, because the given semicircle is symmetric about this line, therefore y2 equal to radius of a semicircle, that is equal to 50 mm. Now here capital R equal to radius of a quarter circle, so therefore a1 equal to pi r square by 4 is the area of a quarter circle, and the area 1 equal to 7854 mm square, and small r equal to 50 mm radius of a semicircle. Semicircle is a hollow section, so therefore you have to subtract value of area 2 from area 1. So therefore area 2 equal to pi r square by 2 for semicircle 3927. So these are the x and y values from figure. Now from general expression, x is the distance of centroid or center of gravity from y-axis, and x equal to a1 x1 minus a2 x2 by a1 minus a2. Why I am taking here, why I am taking minus sign for area 2? Because the given entire section is quarter circle as section 1 as solid and section 2 is a hollow, so you have to subtract area 2 from area 1. So therefore I consider negative sign for area 2. The answer is x equal to 63.65 mm. Similarly, yc is the centroid or center of gravity from x-axis. Yc equal to a1 y1 minus a2 y2 by a1 minus a2, and the answer is yc equal to 59.86 mm. Now here I am showing the final position of a centroid for this composite section. C1, C2 are the individual centroids. C1 is the centroid of a quarter circle, C2 is the centroid of a semicircle, whereas capital CZ is the centroid or center of gravity of an entire composite section. It is at a distance of xc equal to 63.65 mm from y-axis, and yc equal to 59.86 mm from x-axis. So CZ is the final answer for our problem. Now coming to the next problem. This is also a composite section as well as I section. Now how to solve this composite section? First of all, the given section is split up into 3 sections. First of all, I consider section 1 as a rectangle having dimensions base B equal to 80 mm and height or depth D equal to 100 mm. So first I consider this rectangle as section 1. Now I consider second section, that is a semicircle. So this left side semicircle consider as section 2 having radius r equal to 30 mm and this right side semicircle considered as section 3 having same radius r equal to 30. Section 1 is a rectangle, section 2 is a left side semicircle, section 3 is a right side semicircle. So from centroid formulas, the location of centroid for a semicircle lies at a distance of 4r by 3 pi from baseline, r minus 4r by 3 pi from curved surface, and the centroid lies on horizontal this line from r, from this corner to this point r, and from top corner to CG the distance is r. Similarly, for this shape, the location of centroid is same, but the difference is rotation. Here also the centroid lies at a distance of 4r by 3 pi from this line, from baseline, and r minus 4r by 3 pi from curved surface. So in both cases the answer is same, but the main difference is the reference axis. For rectangle, it lies at a distance of base by 2 from bottom edge, and d by 2 from top corner. So these are the formulas we consider in our problem. This is a question. Here I consider x-axis at the bottom edge and y-axis at the left side edge, and capital R equal to 30 mm for radius of a semicircle, and B equal to 80 mm for base of a rectangle, and D equal to 100 mm for a height of a rectangle. Now I am drawing the diagonal lines for locating the individual centroid. C1 is the centroid of a rectangle at a distance of x1, from y-axis, and at a distance of y1 from x-axis. Here the value of x equal to base by 2, x1 equal to base by 2. So the base of a rectangle B equal to 80 mm by 2 is the answer for x1, and y1 equal to height or depth by 2, that is d by 2. y1 equal to d by 2. Now coming to the second section, that is the left side semicircle. C2 is the centroid of a semicircle at a distance of 4r by 3 pi from baseline, from this y-axis line. Now y2 equal to y1. Here the centroid C1 and C2, C3 is the centroid of a right side semicircle, lies on same reference line, that is lies on horizontal line. Therefore the values of y1, y2, y3 are same, that is height by 2, that is d by 2 equal to 50 mm, y1 equal to y2 equal to y3 equal to 50 mm. Now x3 is equal to total base B minus this gap, that is 4r by 3 pi. From here to here the value is 4r by 3 pi. So therefore the total base from here to here 80 mm. So x3 equal to 80 minus 4r by 3 pi. So these are the values. Now these are the section numbers, these are the sections, dimensions, areas, and x and y values. Here for rectangle, base B equal to 80 mm and height D equal to 100 mm. Therefore area 1 equal to area of rectangle 1 equal to base into depth, that is 80 mm into 100 mm, that is 8000 mm square. And for left side semicircle, radius r equal to 30 mm. Therefore area 2 equal to pi r square by 2. Similarly area 3 also same semicircle having same dimensions. Therefore area 2 equal to area 3 equal to pi r square by 2. Now x2 equal to 4r by 3 pi and y2 equal to how y1 equal to y2 equal to y3, x2 equal to 4r by 3 pi from here to here 4r by 3 pi. Next x3 equal to total base 80 minus 4r by 3 pi. So these from general expression, x is the distance of centroid or center of gravity from y-axis. So x equal to a1 x1 minus a2 x2 minus a3 x3 by a1 minus a2 minus a3. Here also area of a rectangle a1 is a solid section, and semicircle, left side semicircle and right side semicircle, both are hollow sections. Therefore you have to subtract area 2 area 3 from area 1. So therefore I consider negative sign for area 2 and area 3. Finally the answer is x equal to 40 mm, that is half of the base. Similarly for yc equal to the distance of centroid or center of gravity from x axis, formula is same. Yc equal to a1 y1 minus a2 y2 minus a3 y3 by a1 minus a2 minus a3. Answer is yc equal to 50 mm. In next slide I will show the final position of a centroid. Here C1 is the centroid of a rectangle, C2 is the centroid of a left side semicircle, C3 is the centroid of a right side semicircle, whereas CZ is the centroid or center of gravity of an entire composite section. It lies at a distance of x equal to 40 mm from y-axis and at a distance of yc equal to 50 mm from x-axis. So C1 is equal to CZ. So therefore the centroid or center of gravity of an entire section lies at C1. Therefore xc yc are the coordinates of centroid. X equal to 40 mm and yc equal to 50 mm. Thank you.